This video is going to serve as an introduction into Chapter 8 in the Alexander Holmes OER textbook. Chapter 8 introduces us to the world of confidence intervals. And basically, before we start calculating specific confidence intervals, we have to talk about what do they represent and how are they developed. And if you think of a confidence interval, if we look at a variable that we're familiar with, if we look at a mean calculation, we have two different mean calculations. We have an x-bar and mu. The x-bar does not represent the truth. The x-bar represents some estimation of the truth. This is going to end up basically serving as our point estimate. This value is the truth. That is hard to find in most cases within statistics. We are very clearly now moving into the world of inferential statistics where we don't have this number available very often. But instead, we can construct around this point estimate. Again, this point estimate is a sample value. It's a statistic that we can use to estimate this population parameter. But we can construct around that a confidence interval in which the truth is likely to occur. Now, bear in mind, this is true for many types of different variables. We could also look at a standard deviation calculation, and we show that as a point estimate. It's a lowercase s. When we show that as kind of the truth, the whole thing, we show that as funny looking u or mu. Eventually, we will look at things like correlation. And when we show that as a point estimate, we can look at that as R. We show that as a population parameter. We could look at that as rho. So there's a series of different types of variables that we could talk about this difference between a point estimate and a confidence interval. All right. Now, a confidence interval, where we're going to start off is we're going to look at a familiar distribution to us. We're going to look at a z distribution. And we're going to say around this sample value, we are going to provide or calculate an interval in which the truth is likely to occur, right? Where is this value? Well, we may not be able to find it specifically, but we can find the areas where it's highly probable to appear, right? So we can say, for example, we want our confidence interval to be 99%, all right? In this case, we would say we're going to be 99% sure that we're going to find two values, two numbers, in which this point or the truth is likely to occur. All right. Now, in the next video, what we're going to do is actually show how demonstrate the calculation of a confidence interval using a large sample size or a z distribution. But just to kind of jump ahead a little bit, we're going to start off and we're going to say this is where we left off after we talked about the central limit theorem. Right. We have this familiar equation to us. We can use those same inputs and find an equation for a confidence interval. Again, at some specified level of confidence. All right, and we could say x bar plus and minus, for example, z times the standard deviation over the square root of n. This is familiar to us. This is new, but if you look at these two equations, they have basically the same inputs. We got z, we've got our x bar, we've got our x bar. I think u or mu is basically covered because that's what we're ultimately looking for is this truth. And then, of course, we have our standard deviation and our sample size. So we're going to look at this very much that it's just an application of something familiar in a new way. But it's a very powerful concept for us to be able to say, now we're in the point where we can go in, and even though we cannot find this value, we can find where it's likely to occur.